All right. So, in the world of fitness and nutrition, we focus always on what we eat and what we put inside our bodies. A lot of times we make good choices, sometimes we make bad choices. Good choice, bad choice. What happens when we pick something bad like chocolate? We get a good energy rush, but then it drops, and we're stuck. But if we make healthy choices, we'll have good sustained energy to help our body through whatever task we're trying to get to. If you think about that relationship, it's the same with your energy analysis model. So when you're working with Revit and you're building your energy analysis model, think about that. Good evening, my name is Zan Ta. I'm with Repro Products, along with my co-speaker and good friend, Joe Gould from Autodesk. And this is Energy Analysis in Revit, a how-to guide.
I'm up already?
Yes, sir.
All right. I don't have any cool analogies when it comes to food or anything like Zan has, so I'm going to stay away from that. But, you know, there's a cliche that I'm sure everybody in here has heard before: what happens in Vegas stays in Vegas, like last evening, for example. But with that being said, what you guys take from here today, don't keep it in Vegas. I encourage you to share it with your colleagues, share it with your firm. If you guys don't do energy analysis right now, I encourage you guys to take a look at it. We at Autodesk design responsibly, even when we're doing things like interior fit-outs for our own buildings. We're quite often testing our buildings for different ways to design around energy consumption. So real quick show of hands, and by the way, it's a great-looking crowd. Glad everybody could make it. How many people right now are currently doing some kind of energy analysis, whether it's in Revit or some other kind of platform? Wow, a lot of you. Fantastic. So with that being said, I'm going to handle the PowerPoint portion. And I know you guys are going to love me already because of that. I've managed to whittle it down to about 70 slides, so you guys don't have to worry about that. I'm going to go through it real quick. And then I'm going to turn it over to Zan so that he can show you guys the real good stuff, the software. So he gave me the boring part, and it is his class. So that being said, I'm going to take you to at least a pretty cool, and by the way, I didn't build this, Zan did, a really cool PowerPoint that he did do to keep you guys entertained. Here's some of the objectives that we're going to learn today. We're going to learn, like Zan said, about what kind of data that we put inside of our model. There are a lot of different types of data that we can input. There's going to be a lot of different ways that we can input that data, and there's going to be a lot of ways that we can extract that data from our model around energy analysis, and Zan will show you. When we talk about exporting, there's a lot of different ways we can export it. We can export an HTML file to further investigate around energy consumption, or we can take it out to Green Building Studios where we don't have to model and we can make choices through a series of pull-downs. And then finally, we're going to learn how to analyze in Revit and also inside the cloud. This is nice. I like this. So steps to prepare for an energy model. And again, I'm going to breeze through this because I really don't like PowerPoints myself. Here's the steps that we're going to take a look at today live. We're going to talk about importing BIM data from both project level, energy settings. We're going to talk a little bit about materials. We're going to input rooms, spaces, and zones, and these zones carry parameters and data that we're going to leverage inside our energy analysis. We're going to define some information, some reports. We're going to schedule data. We'll talk a little bit about details, or we'll actually show you details. We'll run some heating and cooling loads. We'll export this out to gbXML, finally. We'll run an energy simulation via the cloud. So again, this is kind of just a blow-up, and I'm not going to spend too much time on this because I want to get to the good stuff. Importing BIM. This is importing BIM data. So here's some of the data that we're going to put in: identity data, other information, locations, what kind of typology it is, etc. We'll define some of the more detailed parameters, such as, again, let me see here, building envelope, what phase of project we're in, how we want to export this, what level of complexity that it takes on. We can talk a little bit about, or we'll spend a little bit of time showing you guys about thermal properties, so assigning thermal properties to materials that we can then leverage that data inside our energy model for more specific or more detailed energy studies. We'll add some rooms, some spaces, and zones. You see me cruising through this, huh? We'll define some space limits as well. And then from there, we'll run some analysis reports. We'll schedule some data. We'll talk a little bit about some of the details. Zan will show you. We'll run that heating load. We'll do a building summary, and then finally a zone summary as well. And then Zon will take it out. We'll export it out to gbXML. And then we'll open it in Green Building Studios. I don't know if you're going to make any design changes inside there or different run alternatives, but we'll go through Green Building Studios. And then we'll talk a little about running energy simulation in the cloud. So just some housekeeping. There are some energy analysis courses that you guys can take. Some locations, if you guys are interested in that, see me after the class or see Zon after the class. And of course, as always, you heard today with Carl, education free. So all of our software, all of our applications, all downloaded here at autodesk.com/students. And then finally, we encourage you guys to, if you're not certified, take a look at maybe getting certified on some of our softwares.
Especially since it's free.
Especially since it's free.
And I just found out that Revit is now just, not just Revit architecture, but they have Revit MEP and Revit structure certification.
So I think, and then finally, if we have time, Q&A. If not, and there's something that we haven't covered, again, I urge you guys to introduce yourselves. A lot of you I've met before, but some of you I haven't. Stop by after, introduce yourself, ask some questions, and we'll talk about it a little bit more in detail. That, I guess I'll turn it over to you.
Thank you, Joe. Appreciate it. And don't forget, when the class is over, go ahead and make sure you get your surveys taken care of. And if you get a chance when you're in the exhibit, come visit our booth. It's 92. And I hope you guys have a lot of fun. And from there, we'll go straight into Revit. All right. When we're working with creating our energy analysis model, there are two approaches. One is strictly from a conceptual massing level, where we make assumptions about the spaces, the faces of each of the buildings, and assumptions on construction. That's one approach. The second approach is actually doing an energy analysis model from the actual building components, the families themselves, the actual building. And that's where we are going to be approaching it in this demonstration. Now, when we're working with the software, the perspective is I'm either an architect or an MEP engineer, and I'm building a clean energy analysis model from scratch. This is just a sample of a model that I was working on, and we'll just go ahead and we'll start from a brand new model. Since we're dealing with energy analysis, typically the mechanical default template file should be fine. In most conditions, we have an architecture model coming from the architect, and we'd like to go ahead and leverage that. So if we go ahead and we link in the Revit file, it'll come on inside, and if you need to, you can actually change your display in the discipline to coordination so that you get a little bit more visual pop. Since this is a linked Revit file, when we're actually using objects such as space objects, it will not understand its boundaries as a default. So typically, you want to make sure that you look at its type properties and make the room bounding adjustment. Anybody here not know what room bounding means? Great. Okay. So now that we've go ahead and specify that, we can either go through the approach of just modeling our MEP model, or just take it for what it is and start putting in the things that we need to put in. If we head over to the Manage tab of the ribbon, Project Information, we have the general data we talked about earlier, Step 1, where we're inputting basic information that is populated on all the construction document sheets. More importantly, if we click Edit under Energy Settings, we'll have this window. And in here, we can go through the process of inputting the correct BIM and data that we need to really have a good, solid output. So when we look at the building type, we can specify whatever type that we want to. And since this is exercise, I'll go ahead and choose, say, Exercise Center. Now, I chose Exercise Center, but a lot of people will ask, well, where's the data that's coming from that? If I back out of this just for a second and head over to the Manage tab, go to MEP Settings, Building Space Type Settings, you'll see you have building types, and there's a whole list of pre-made that you can pick from. And as you select any one of these, you'll see on the right-hand side all the data that is assumed. This is just industry standard data. You can always change any value you need. And so, even all the way going down to things like occupancy schedule and specifying how often is it running. For example, is it 24/7, 24/5, so on and so forth. You can also look at the lighting schedule as well, specifying that time and that interval information. So this is where all this data is actually being pushed into the building types here.
Is there any way of creating a new one?
Right now, no, until we can, work on it some more, as far as I understand. So if we go back over to our project information under energy settings, and we've specified the type. Oh, by the way, if you get that jump, pull this over. It's kind of a weird hiccup. So we go through and we specify things like the building type. And I'll specify, say, exercise center. We specify the location. And the reason we specify the location is because it's actually going to go out to Google mapping systems, local weather, satellite data. And here you actually specify the proper location of your site. And let's just say I put in Las Vegas, Nevada. You'll see the map adjust. We can go in here, we can zoom in, and we can physically place this wherever we need to, hypothetically on our site. Now, if we zoom out, the closest weather station icon you'll see is here. And the software will automatically look for the closest one and a list of all the ones nearby. And it will default to using this information to help in the analysis aspect of it. You don't have to pick the closest one. You can pick any other one you want, but typically the closest one makes the most sense. Once that is specified, we can go through and we can input all the other information that we're dealing with. For example, the export category. We have rooms and we have spaces. Anybody here know the difference between room objects versus space objects and the understanding of why we use one versus the other? Yes? No? Yes? Oh. Okay, good. So for the purposes of quick explanation, when we look at a room object and we place it inside our model, it'll obviously know things such as length, width, height. It'll know its restricted areas because of room-bounding objects such as system families, floors, walls, ceilings, things like that, roofs. But it doesn't contain the analytical information such as mechanical and electrical data. And so for the purposes of energy analysis, it is better for you to work with spaces and use spaces. Okay? So here we choose spaces. We have export complexity. And it goes from very simple to complex with mullions and shading surfaces. Basically, the lower you go in this list, the more the Revit software is analyzing every single face of every single object and taking a look at it from position as well. We talk about sliver space tolerance. This is where you're working and you've got, say, two spaces, and maybe it's a chase wall, or maybe it is a plumbing wall. And that plumbing wall internal distance is greater than a foot. If that number is greater than a foot, which is the default, then you'll get a warning from Revit saying, hey, do you want to include a space object to account for this space? Other things you'll want to consider are chases, curved corners, slivers, just dead spaces. If there's too many of them, the analysis will be not as accurate as it should. So you may have to select those walls and make them not room bounding if necessary. And we'll look at this when we actually get into it. Moving forward, we have things like the building envelope, and we can either choose a function parameter or identify exterior elements. Use function parameter is the default, it's the legacy. And basically what that says is it looks at the function of the object. For example, on a wall, is it an exterior wall? Is it an interior wall? Is it a shear wall? Things of that respect. That's what use function parameter is doing for us. And if you decide to switch this to identify exterior elements, we can specify an analytical grid cell size, and it looks at the face of every side of the building and places that grid system and looks at each portion and analyzes it this way. Obviously, we have to input things such as building services, construction, building infiltration class. Here, they have loose, medium, and tight. And And actually in the handout that I gave you, it actually has the numerical values of the differences. What this is basically specifying is how much air will enter the building. And if it's set to tight, it's a tighter envelope. Less will get in, less will get affected. Okay. When we work with obviously the reports that are generated, you have simple, standard, or detailed. I typically choose detailed because I want to be able to see the total summary of the building and the zones and spaces. And we go through this entire process of inputting all this data. Now, over here, under Energy Model, you'll see a lot of features that are grayed out, that we can't make changes to. And the reason is because we're actually working from that secondary aspect. We said we're actually building a Revit model and doing an analysis of the building components. If we're doing just strictly an energy model of conceptual massing, and over here under Analyze tab of the ribbon, Analysis, Energy Analysis panel, if we choose this option to use conceptual mass model, then what happens is back in our energy settings, this information down here is no longer grayed out, and we can input those values. So we have chosen to work with doing the energy analysis as building components. And obviously, we have to go down here and specify things such as the building operations schedule, the HVAC system. Obviously, and by the way, my background is not MEP, it is architecture. So those are the MEP engineers in the session tonight. You guys have better understanding of what systems you're actually picking and working with. So you go ahead and you've specified all this information. You now need to actually put in things such as rooms, spaces, and zones. So over here in the Analyze tab of the ribbon, I can click space. And you'll notice that until it gets placed in an area that is confined, it won't do what's necessary. So if I click here, it'll place that space. I can also click place spaces automatically, and they'll all get placed. Now, they all just say space and a number. It's kind of annoying, because you end up having to go back and say, well, what's the room number and what's the name, and I have to retype everything. Well, actually, you don't have to. Up on Autodesk Exchange Apps site, there is an add-on you can get for free. It's called Space Naming Utility. Download it, install it. Once it's installed, it'll go into the Add-ins tab of the ribbon. You can click the command, and it'll ask you, how do you want to coordinate the information? Just the names and numbers? Both names and numbers, or whatever your choices are. And if you hit OK, it'll actually coordinate all the room names and numbers from the Revit architecture linked model and push it into your MEP model. Now, when we place the spaces initially, you don't really see them. If you actually open up Visibility Graphics dialog box, for those that don't know, just type in VV or VG, or go to the View tab of the ribbon and click Visibility Graphics. In here, you can filter by the discipline, scroll on down, and under Spaces, you can actually put a check mark for Interior and Reference, and this will give you the ability to see the spaces easier. Okay? Now, just because you place the space in Plan, it doesn't necessarily mean you have it correct. What I mean by this is, as you place spaces, because we're working with a live 3D model, you want to look at every aspect of it. So go look at it in section. Make any adjustments that you need to make in your section. Turn on the visibility of your spaces again. And now you get a chance to see what have you placed and how has it been placed. Okay? You'll notice we have plenum spaces in most of our buildings. And if you don't put space objects in there, you're negating that amount of space, and the calculation will be incorrect. So make sure that you've placed the spaces properly. Make sure you've selected them and adjusted their offset limits as well, the height, so that you have good volume count. When you're finished, go take a look at your space. Select it. Scroll down. You'll notice you'll see in the instance property electrical lighting data, loads, and mechanical flow. And by default, it will have nothing. If we scroll further down, you'll see under Energy Analysis, there is a space for you to click Space Type. If you click inside here, you can go ahead and specify what kind of space it needs to be. So for example, I will set this to exercise. And it will look at all this data, and it will assume all of this information for that space. This is the arduous part of doing this, because you may have hundreds of spaces in your Revit model. There's no way getting around it. You have to work with each space and select it and specify the BIM data. You had a question?
No, there's a way to do it. You create a schedule.
Correct.
You just check, itemize all instances, and so then all your offices would go to one office and do that,
True.
that type, and your
True.
groups of.
Yep. So the solution was, a faster way to work with all the spaces and naming them and setting their offset limits is create a schedule. Awesome. Makes sense. If we go through the process now, even though things are not completely finished, our inputting of all the BIM data is not finished. If we just run an actual heating and cooling load analysis and accept the defaults, even though they are not correct, and you will see this, it's okay. The reason we run the calculation is just to get an initial number of that space that says this is how much CFM, for example, is required. So disregard your report that you're getting right now because it's going to be incorrect. And I'm not worried about that. That's not the reason I did that. The reason is now that I have that space selected, if I scroll down, I now have information that really says, hey, I have under mechanical flow, I have specified airflow, and it's automatically generating that number based upon the space that I told it was going to be with all those values you saw earlier. And the actual supplied airflow is also still 0 because we haven't actually placed our diffusers. So when we go through the process of putting in our diffusers, we can go ahead and place them and place as many as we need, obviously specifying the correct flow. So if we look at this particular space, and we see that the specified supply airflow is a little over 1,000. If I take 2 air terminals in here, just put them in for now, and change this to, say, 600. Then when we go back and look at our space, we'll see that we've actually supplying 1,200. So again, as an MEP engineer, you guys know better than I do what those values need to be inputted as you're putting these objects in. And so you go through the process of inputting all that data. When it's all said and done, run your analysis. Now, back over in this other model, which I already have set up, if we go back to the Analysis tab, and we go back to Heating and Cooling Loads, it'll bring up the Heating and Cooling Loads window. And in here, you can actually see all of your spaces. And you can zoom and you can isolate whatever you need to do. Again, here under the General tab, is all that rich data that we said we had to specify earlier. It's a good second verification check to make sure you have the data you need. Go to the Details tab, and what you need to verify is, are any of these spaces having any yellow exclamation points? And if they do, that means you have a problem. And if you click this icon here, it'll tell you whether the space, what the issue is with the space. Maybe it was created, but it wasn't placed. Somebody deleted it, and it wasn't deleted out of the project. Just because you delete it from a view doesn't mean it's off the project. Maybe the space has not been defined, its upper limit hasn't been defined properly. So you have to figure out and go to that actual space and look at the condition of your design and figure out what needs to be changed, how do you need to alter it, and get it corrected so that when you're all said and done, you won't have any errors. This is not to say that if I click Calculate, it won't give me the report that I need. The more errors that you have in here, the more incorrect your report will be at the end of the day. So as long as you have all of these issues resolved and you click Calculate, it'll go through the process of doing an analysis of your model within Revit and give you your project summary. And so here you've got project summary, you've got building summary, you have level summary, all your zones, and if you scroll down further, it'll actually break it down into spaces as well. And so this will give you an initial internal Revit analysis report of your model. When you're going through this process, one of the tools that Revit has that will help you out is turning the system browser on and switching to zones and verify all your zones are set up properly and all your spaces are set up properly. This will help you because it highlights the information, okay? You can right-click it, you can hit show, and it'll take you to the particular view that gives you the best visual indication of that object. Okay. So we've just gone through the process of creating an energy analysis MEP model of just spaces. You notice I didn't go through the process of building the model as in floors, walls, ceilings, roofs, things like that. If we're looking at it from the aspect of just the energy information and just getting reports, then that's fine. But if we're concerned about, I really, really want to model my Revit MEP building, then use features like Copy Monitor. Okay? Copy monitor all the walls, the levels, everything you can, and build what you need to build. Ceilings, roofs, okay? Even if necessary, reference planes, and get all of your spaces set up properly, get all of your zones set up properly. And once it's tight, then run the analysis. Okay? So that is doing an analysis within the software. As we saw earlier in the PowerPoint, there are other ways to do analyses. One is you could take the information and use subscription-based tools to run the calculation for you on Autodesk servers. And if we go back to the Analyze tab of the ribbon, you'll see under Energy Analysis, there's a feature for Run Energy Simulation. If you click this, it will let you know that it's going to be building an energy analysis model for calculation purposes. Let it do it. It'll bring up a second prompt that says, I need to give you the name, all the data that goes with it, and whether you want to create a new analysis or if you want to append to an existing one that you already have that you might have done, prior, a week or two prior. When this is all said and done, you can go through and click the results. And so, for example, here, under the Results and Compare window, you'll see one analysis that was already created, and you'll get an initial graphic of what it looks like. And if you scroll down, you'll get more information about the performance factors, the energy use index, your life cycle energy use costs. And as you scroll down, you'll even see things such as carbon emissions, annual energy use cost. Okay? This is the same information as if you bring it into Green Building Studio Analysis, the reporting information that comes out. This is displayed differently, and it's not analyzed as deep. And we'll look at the difference between this versus GBS. Okay? If you are running more than one scenario of energy analysis, you can go through the process of picking as many as you want and hitting compare. It will place them side by side, and you can just go through the process of initially looking at the differences of your results. In this Results and Compare window, there is a beta feature called Solon. What this does is it gives us a very quick synopsis picture of all of your results for monthly temperature. Obviously, as you can see, as I hit every single node, it'll tell you what the temperature is, the wind rows, your performance scenarios, and again, like I said, as long as you place your mouse on each of the nodes, you'll get the pop-up information. And scrolling down, you have more data as well. There is also, brand new under beta, is energy cost range. And what this does is it gives us the ability to see what our cost mean index is. And if I make adjustments to our ranges, we can start to see how it gets adjusted. Okay? Lastly, the third way that we do an analysis is with Green Building Studio. After we've gone through the process of inputting our model and setting all the information that we can actually export it out to gbXML, Green Building Extensible Markup Language. When you do this, it'll ask you to, again, verify all of your settings and go through the details again, get it all set up, hit Next, and it will ask you to give it a name and a location. You just save it out. When you're done, the file is just an XML file. And let's see, where did I save it? Here it is. If you just double click it, it takes a second or two. It'll open it up in HTML format, and it's just coding. You can't really do much with it from at this stage of the game. It's not something you can just work with, that you can read. What you end up doing is taking that information and going up to Green Building Studio. So if I go to gbs.autodesk.com, this is subscription-based feature, so we need to log in. And so once you've logged in, the first thing you'll see is My Projects. And it lists all the projects you've done in the past. And I built one a while ago, and I'll just show you some results. When you click the actual project name, it'll give you your base run, and all of the alternate runs it automatically creates for you. What are alternate runs? Anybody? Okay. Alternate runs, when you're working with GBS, basically it says, well, what if we decide to take the building and reorient it, say, 15 degrees, or 35 degrees, or 90 degrees, or if we change the position of where we want the sun to come in, and how much lighting. So what it does is it automatically just creates multiple iterations of tests for you. You can look at the run chart. Yes, you can. Yes, you can. So when you're creating the alternates, it'll ask you for a name. You give it whatever name you want, and you set up whatever parameters that you want. And so back here, for example, if I click the base run, you'll see the information that it's working with for this base run. Bless you. And you can set up alternatives if you need to. And if you choose to create a design alternative, it'll take you to your run list again. And you can give it whatever name that you want to give it. And pick whatever scenario system that you want. Save it and run it. And it'll go ahead and go through the process of giving you the results. Now, if we need to, we can take a look at things such as project defaults and seeing what information is being used, project details of the name, the building type, the schedule. All this information we specified in the BIM model earlier in the software is getting pushed into GBS. Okay? And for this project, I put it in Korea, just because it's a martial arts school. I kind of threw together. And then, so here, this one basically shows what I've already done. So let's go through the process of actually creating a GBS. And so you'll go through the process of saying action. You can upload a gbXML file, or let's just start from the very beginning. We'll go to My Projects. We can create a new project. It'll ask you to give it a name. Call it whatever we want. Let's say Energy Model Example 1. And we specify what kind of building type it's going to be. We specify the schedule that we know it's going to have. This one will be a test. Any notes that we need to input, hit continue. It will then ask you for the location of the project. So put in the location. Hit continue. And it'll ask you some terms of use and specify the one that makes the most appropriate sense for you, and click Create Project. What it's going to do is it's going to take that and set up a project for you, and now it's going to say, hey, I need data. I need that gbXML file. Where's that file? How do I put it in? So over here under Actions, if you click it, you can say Upload gbXML file. Browse to go get your file. And pick the one that you need to work with, the one that you made earlier. Hit Open. It'll ask you to save the run, whatever you want to call it. Let's just call it Energy Model Test 1. and then upload that gbXML file. What Autodesk Green Building Studio is going to do at this point is it's going to look at that gbXML file, look at the data, digest the data, create the base run. As soon as the base run is complete, you can start to look at the results. But while you're looking at the results, it will automatically create all the alternatives. And it will just keep doing that until all the alternatives that they have as a default is set up for you. So you can just start to see the results. Okay? I've been doing a lot of talking. Questions? You guys are a quiet bunch.
Once you've done this, can you put this data into a sheet form? Is there a method to plug and play it in if you submit that to the
Honestly, I don't know. I'd have to ask my team at Autodesk to see if there's a way to pull out the reporting information and use it in other formats. I'm pretty sure you can.
Has any of this, or I should say, what's the validation for it? How do we know that the information is accurate or real?
It's a good question. I would probably say looking at historically all the other analyses that have been done from other Autodesk projects and doing a comparison between what's been out there and what's been done and is real world data versus what your theoretical is, you'll get a better sense of whether the information is accurate or not. Now, when we're doing this kind of workflow, it's not an exact science, we know that. The information, the BIM information you're inputting into your model is very granular. So if you make minute changes to property information such as spaces or zones from a object by object level, your analysis is going to be different. And so what happens if you decide to change your model a month later and you need to do another analysis of it? Well, because you've changed the design and you've changed the rooms, you've changed all the spaces, your results are completely different. That's just the nature of doing this. Okay?
Is the analysis engine based on like a piece of software? Are there elements of Ecotech, for example, that are running?
It's based on the DO 2.2 engine. There is inside the help file, and if you want to see me after class, I'll show you exactly where all the data comes from. But I believe it's in the help file, and it'll direct you exactly where all that data is coming from. But just come talk to me after.
Okay.
You're welcome.
All right, so real quick as a recap, let's go back to my PowerPoint. So we've gone through that process of inputting the BIM data. We've inputted all of our rooms and spaces and zones and our diffusers, specifying things such as our limits and all the CFM data that we need. We're doing the initial analysis report and inputting the adjusted data based upon the raw report that we initially saw. Once all of our objects and our spaces are set up properly and the adjustments have been made, then we can run a proper heating and cooling load analysis from within the software. We've also gone through the process of exporting it out to gbXML, and from there, putting it into the actual software. The class that they said in the PowerPoint earlier, we said that Autodesk has some new energy analysis classes that you can take online. And I went through one of them 6 months ago, roughly, and it's about a 2.5, 3 month class, if you will, quote unquote. And it's pretty grueling, it's pretty deep, and it goes through Ecotech, it goes through GBS, goes through Revit energy analysis. And when you're all set and finished, if you pass with a 80% or higher, you'll get your certification for building analysis certification. And then lastly, we did talk about pushing this information via the subscription cloud data utility. Now, those features, again, like I said, you have to have a subscription account. And even if you don't, you can do the analyses, but you're not going to get all the data that you need, because when you're on subscription, you have much more capability. For example, cloud credits. You have more to work with. You have a bigger space, online space to work with. And you have a lot of other features that we don't initially see in the Revit software. But if you're not on subscription, it's very limited data that gets pushed out. And let's see. So, yep, that, good. And real quick, how many people here are part of the education system? Good, good. Yeah, being able to get to having all the Autodesk software at your hand for free is amazing. And as far as I understand, if you are in the realm of education and working with the software like this, you get a pretty decent amount of cloud credits to work with. So a lot of students are using this to do their designs and pushing that envelope as well. Okay. And then lastly is any questions and answers we might have? Yes, sir.
So I'm an architect. I've got my architectural model. The designer is supposed to, have all curtain wall everywhere, whatever, without putting in spaces, without putting in diffusers, getting it from any or whatever.
Mm-hmm.
How can I use these tools to show the client or the designer, this is kind of this is why this design is worse than that one.
I can handle this one if you want. Is this on? Testing? Yeah, I can handle this one because I was actually going to ask him that about 2 seconds ago. A lot of times when I'm presenting this to clients in architectural firms, that's my background specifically. What we didn't talk about is the conceptual energy piece. So creating masses and forms and then doing a series of conceptual energy analysis studies prior to even getting to this level. What you're talking about, I'd probably start on a very conceptual mass level, and maybe the south and the west wall might be, or may not be, depending on what you want as far as design, full storefront or for full curtain wall. And with that, you have the ability to change those materials per side without having to model any of those details. So you can actually take that then, and like Zahn was showing earlier, he was showing it on more of a building enclosed envelope session. You can also do the very same thing via subscription on a conceptual level, and it'll show you, rather than placing zones and things like that, it'll take into account conceptual construction. So being there's no walls, doors, or windows, it's going to conceptually make some assumptions as to, this is what this is what our value it has, and it will spit out a number. What I don't like about it, personally, and I believe in being honest, is that I'm talking on a conceptual level to a potential client. It will show it down to the dollars and cents. And a lot of times when I do a comparison of maybe design options as to, Mr. Owner, do you want the L-shaped building or the O-shaped building? The O-shaped building is going to cost you this much less to heat and cool than this one. I pitch it as more of a percentage. It's going to cost you 40% more, 40% less. So I would do that all conceptually. And then once I got sign-off, then I'd go to Zahn's level.
And when you're talking about doing it in that aspect, you can do the energy analysis either within the conceptual massing environment by itself, or doing the mass, bring it into the project environment, do the analysis that way. Or if you really, really need to, then use your building maker tools to throw wall by face, roof by face, floor by face, all that, and get some basic building structure down if you have to. So, good.
Are you saying in your effort, when you're talking to the client, the conceptual aspect, is there a way to show it just in percentage, or no, it always drills it?
It drills it down, but it's one of those things where I'm just going, okay, I know it's down to the dollars and cents here, and I kind of laugh about it a little bit. Just know that the differential between the O shape and the L shape is $4 million over the cost of 30 years. So whatever delta that is. But even though it's down dollars and cents, I just tell them, quite frankly, this number is going to change. It will change as the design refines. It may go up, it may go down, but at least this is our conversation starter. And a lot of times I'll start in our other software, Formit, do my design there, and then bring that out with the RVT file right into Revit and do my energy studies that way.
I had a question over there.
The engine works outside of the US, but sometimes some part of the platform doesn't work in that area. The simulation is custom simulation for that.
I've heard that. Yeah, I've heard that before. I actually have a call into one of the gentlemen because I gave a presentation in Canada. So I actually have a call in. If you wouldn't mind, drop me your card, and then I'll get in touch with you on that one. But I literally asked that same question last week. Don't have an answer for you yet, though. Sorry.
We had another question over here, I think. Yes, sir.
Yeah, it's not for your energy settings tab
Yes, sir.
and the energy model. You had the analytical phase surface.
Yes. Oh, okay. Hang on. Let me go back.
The resolution,
Yes. So here, manage project info, edit, analytical space resolution, analytical surface.
Is that a good rule of thumb?
I'm sorry?
Is that a good rule of thumb, 18 and 12?
Well, that's just the default, and that's just what industry says to work with. But there's no hard rule to say has to be this. It's up to you to make the experimental change. You know.
Does that change like your run times dramatically?
No, because the actual running of the report and getting a finished, as you saw, was like this. I mean, I've never seen it run more than a minute and a half to get a report. I mean, usually it's 30, 40 seconds, and I've got a report. So.
Those calculations are occurring over the cloud, right?
I'm sorry?
Are those calculations occurring over the cloud that's using those settings? Because then you can probably use more finer settings if it's not really a matter of speed.
Well, okay, so when we talk about analytical space resolution, what this basically means is that when we look at the spaces, depending on how close they are, if they get further than 1/6, then you're going to have issues and problems with the analysis. That's what this analytical space resolution number is working with. So the tighter it is, the more accurate you may get. But again, it's just one of these values you have to play with to see, does it make more sense for you to go larger or smaller? So, yes?
If I have a building with one part office and one part shops, how can I do with building type here?
So I didn't hear that.
So if he has multi-purpose buildings, so if he has retail or parking or something like that where it might be conditioned or unconditioned, how can he change?
The way I would handle that is I would actually work from the conceptual massing environment level, where if you build your mass objects and build them based upon the space usage. So maybe I have a space here that's for retail. I have a space over here for mixed use, whatever. As you build the mass objects this way and treat them in that usage, and even from the function of maybe zones, then you can actually separate and it'll give you a better report than trying to do it this way.
So then the building type is no use.
I'm sorry?
So building type here will be no use.
Right. I mean, the building type here is that's gonna get affected, very differently. But I mean, at the end of the day, you've got to pick what you think makes the most logical sense for what you're doing.
What the majority of the makeup of the building typology is going to be, and then fine-tune it from there.
Right. All right. Any other questions? Yes, sir.
Do you guys have feedback from users about how accurate the results are? Or?
The clients that we have at Repro Products are just now getting into energy analysis and starting to work with it. So I don't have any hardline data from our clients. Joe from Autodesk side may have.
I actually do. It's kind of proprietary. I can't really release their name, but they were redoing a lot of federal buildings and then comparing. They were using Vasari, which basically same thing. And they were within 11% of historical utility bills when they gathered the data from here and then they went back and compared it. So they were within plus or minus 11%. Can you fine-tune that and get it down even more? Absolutely. But for them, they just need to get some quick numbers and then contrast. But yeah, 11% was not bad.
Any other questions before we close up? I know we're right on dead mark schedule for 50 minutes. So. All right, well, if there aren't any more questions, I do really want to say thank you very much. I appreciate your time. Hope you guys had fun. Don't forget your surveys.